Hello viewers, welcome to Elimu TV, a place where you watch and learn. I am your tutor, Alex Musawa, and I'll be taking you through Physics Form 4, lesson number 40. Our title is Electronics, where we have PN junction. Stay tuned. Objective of the lesson: to describe what a PN junction diode is. Number 2, to describe what is reverse biasing and forward biasing. A PN junction. What is a PN junction? It is made up of the P, that is a P-type material, and an N-type material. That means the P-type semiconductor and an N-type semiconductor meet, and there's a depletion region at the junction that is formed. So an intrinsic semiconductor can be doped simultaneously by trivalent and pentavalent atoms, such that one half of it becomes a P-type and the other half an N-type semiconductor. A junction known as the PN junction is then formed between the two regions. Eventually, the free electrons and holes, the holes are the protons near the junction, they fuse across the junction such that the electrons enter the P zone. As holes move in the N zone, as you can see from the figure, the holes are moving in the N zone, and the P zone is whereby you have the electrons. Recombination of the mobile charge carriers takes place on the other side of the junction. Therefore, depleting mobile charge carriers within the region. As you can see, therefore, this forms a region of uncovered fixed ions on the other side of the junction. The uncovered ions set up a potential difference, which in turn sets up a field that stops further diffusion of mobile charges. The region occupied by the uncovered fixed ion is called the depletion layer. You can see the depletion layer, the depletion region, as you can see there. A potential barrier of about 0.3 volts is set up for germanium and 0.7 volts for silicon. The potential barrier can be discerned as a hill, which the holes in the P region have to surmount for them to move from P-type to N-type zone. We have biasing. Next, we have biasing the PN junction. The PN junction is said to be biased when a potential difference is applied across it. And for this case, the first type of bias, we have the forward bias. A PN junction is forward biased when a P-type region is connected to the positive and the N-type region is connected to the negative terminal of an external cell or battery. As you can see, the P-type is connected to the positive part of the battery, as you can see from the diagram, and the N-type is connected to the negative terminal of the battery. The applied voltage, which is greater than the voltage of the battery is greater than the internal potential barrier, opposes the latter by repelling holes from the P-type. So the holes are going to be repelled from the diagram, and the electrons from the N-type, enabling the fixed ion in the depletion layer to regain their holes and electrons. This reduces the potential barrier and the thickness of the depletion layer considerably, therefore reducing the electrical hill as shown from the figure. Next, we have reverse bias. The PN junction is reverse biased when the P region is connected to the negative terminal, while the N region is connected to the positive terminal of a cell or a battery. The external voltage of the battery, as you can see, is in the same direction as the potential barrier. So what happens? The holes and the electrons in their respective regions are attracted away from the junction by the external voltage. As you can see from the depletion region grows wide and wider. This increases the concentration of the fixed positive and negative ions and increases the thickness of the depletion layer. So you can see the depletion layer increases. However, a small current due to the flow minority charge carriers, leakage current flows. Next, we have a semiconductor diode. This is one-way conduction device consisting of a p-n junction and having two terminals. That is a semiconductor diode. It has a it's also known as the p-n junction diode. As you can see, that is a p-n junction diode. The anode p-type and the cathode n-type are represented, as you can see there. That is a semiconductor diode, and it can either be reverse biased or forward biased. And that is the end of our lesson. I have an assignment for you. Activity number 1, describe how an n-type conductor is created. Number 2, what is the difference between reverse biasing and forward biasing? Our reference comes from KLB Book 4, 5th edition, 2019 Physics book. For more information, contact us on our phone number, YouTube, Elimu TV, Facebook, Elimu TV, and Twitter at Elimu TV_KE. Thank you for watching Elimu TV.